Okay, this is on graphing quadratic functions. Okay, and first on a quadratic function, they talk first in this section about a quadratic equation, and you have actually worked with a quadratic equation when you have solved the quadratic formula. A quadratic equation is in the form y equals ax squared plus bx plus c. The part that makes it a quadratic equation is it's a y to the first and an x squared. Okay, a y to the first and an x squared. These terms have special names. Okay, this one, the squared term, is the quadratic term. The x to the first term, the bx, that one is called the linear term. And the c is just called a constant. Okay, and for this to be a quadratic equation, the a cannot equal 0, because if it was equal to 0, then that x squared term would drop out. That's a quadratic equation. If they write it with an f of x, okay, then it goes from a quadratic equation to a quadratic function. Okay, and then it would be written f of x equals ax squared plus bx plus c. That just tells you that it's a function, so that if you graph it, if it's a function, it passes the vertical line test. No 2 points line up and down. Okay. The graph, and we're going to do a lot of graphing, the graph of a quadratic function is called a parabola. Looks like parabola, but it's called a parabola. Okay, if I say that, parabola. Okay, it's a parabola. Okay, the clue that it will graph a parabola is in the exponents. It's just like most of you can recognize y equals mx plus b, that it's going to graph a line. Well, this is, if it's a y to the first and an x squared, it's going to graph a parabola. Okay, if it's a y to the first, so you look at the exponents. If it's a y to the first and an x squared, it's going to graph a parabola. You can also tell in a parabola it's going to look like this. And in this equation, if the a is greater than 0, so if the a is positive, it's going to open up. And when we graph these, a parabola is going to look like this in general form. It's going to be a curve that opens up. If the a is less than 0, like if I said y equals a negative 4x squared, okay, it's going to open down. Okay, it opens down, so it would open like this. Okay. Okay. Every parabola has what they call an axis of symmetry, that you could fold it over. So every parabola has an axis of symmetry. And the axis of symmetry, from the equation, you're going to take x equals the opposite of b over 2a. So you're going to end up with x equals a number. X equals a number, is going to graph what kind of line? Vertical. So x equals a number. So the axis of symmetry is going to be a vertical line, and we're going to use that fact when we're graphing. Okay, so you will end up with a parabola. It might look like this, and the axis of symmetry splits it down the middle. Okay. On that axis of symmetry, you're always going to have a max or a min point. In this case, it would be a minimum on that graph, and the vertex of your parabola is always on that axis of symmetry. The vertex is the point where the axis of symmetry sorry. The vertex is the point where the axis of symmetry intersects the parabola. Okay? And if it's a lowest point on your graph, it's a minimum. Like this one would be a minimum. If it's the highest point on your graph, like if you get something like that, then that's a maximum. Okay? Max and min. Okay, then the author also talks about the y-intercept. The y-intercept. The easiest way to find the y-intercept is sub 0 in for x, because where it crosses, for any parabola, where it crosses the y-axis, I'm going to, just as an example, if I said where this crosses the y-axis, what's the x value? 0. So if you sub 0 in for x, you can solve for y. And if you take your beginning, take the f of x equals ax squared plus bx plus c, sub 0 in for x, so you'd put a 0 squared plus b times 0 plus c. Well, 0 squared is 0 times a is 0. B times 0 is 0. So the y-intercept actually ends up to be the c value in your equation. So in this form, that c value is the y-intercept. That's where it's going to cross the y-axis. Okay. What's that? Is going to be that c value. You don't have to do that anymore. You just know by looking at it. Yep. Okay. Okay. Yep. That makes it nice. Okay. Now we're gonna practice on a couple of graphs, and you have your graph paper there. So move this down a little bit. Okay. So an example. Say they will give you the directions to graph each quadratic function by making a table. Okay, and they give you f of x equals x squared. Okay. Okay, now a couple things. If you look at that, you should know the c value already. Crosses at 0, right? Crosses at 0. So plot a point at 0, 0. So we know that much. Okay, the axis of symmetry. If you wrote this in the form ax squared plus bx plus c, and the axis of symmetry is x equals the opposite of b over 2a. So my b value, if this is, what is b in that equation? 0. So b is 0. So if you said the opposite of 0, that's just 0, 2 times 1. So this is just x equals 0. So your axis of symmetry is 0. I'm going to make this a little bit bigger. Because there's no linear term. Okay, so what you want to do on these is I would dash the axis of symmetry. So x equals 0 is a vertical line right along the y-axis. So dash that line. Okay. Okay, and then we're going to plot some points. So if you put 1 in for x, 1 squared would be 1. Now look, if you plot this point, use your axis of symmetry. If this is 1 unit away to the right, 1 unit to the left. Okay? Okay, so now try 2. 2 squared is 4. So go 2 to the right and up 4, plot a point. If this is 2 units to the right of the axis of symmetry, 2 units to the left. Okay? And I would probably do one more. This is 3. 3 squared is 9. So 3 and up 4, 5, 6, 7, 8, 9. Okay, so 3, 9. And if that's 3 units to the right, 3 units to the left, and as best you can, it is not, let me explain. A parabola does not look like this. A parabola is not a V. It is a smooth curve, okay, that looks like this. Okay? Okay, as best you can. Okay, let's try another one. Okay, I can do it like this. On the second one, we're going to graph y equals x squared minus 2 by making a table and looking at our clues for the graph. First, where is this graph going to cross the y-axis? At -2. So plot a point down here at -2. Okay. The axis of symmetry is critical. X equals the opposite of b over 2a. You want to write these formulas down enough that you get them memorized. Our b value in this is 0. It's still -0 divided by 2 times 1. It's still 0. So our axis of symmetry is still, so x equals 0. So dash that right along the y-axis. Yep. Yep. So now let's put 1 in. 1 squared would be 1 minus 2, -1. So if x to the right 1, down 1. If that's 1 point to the right of the axis of symmetry, there's 1 to the left. Okay, because it has to be symmetrical. Put 1 in, so you'd have 1 squared minus 2. So 1 minus 2, -1. Make sense? I just picked 1 for a number. 1 squared would be 1. 1 minus 2 would be -1. Okay? And now let's go 2. So 2 squared, if I put 2 in, 2 squared would be 4. 4 minus 2, 2. So 2, 2. So go 2 to the right and up 2. If that's 2 units to the right of the axis of symmetry, there's another one over 2 units to the left. Okay, and let's go 3. 3 squared would be 9 minus 2, 7. So go 3, 7. 3, 1, 2, 3, 4, 5, 6, 7. And then if that's 3 units to the right of the axis, there's another one over here. Okay, and now connect those. So smooth curve. And there is an arrow on these. It's going to continue. Okay? Everybody okay with that one? Okay. Okay, another one. So you have y equals x squared plus 3x minus 1. Okay, first where is it going to cross? -1. It crosses, the c value is -1. The axis of symmetry is critical. So figure x equals the opposite of b over 2a. My b value is 3, so it's -3. Oh, sorry. My fault. Thanks. Sorry. Okay. Okay, then we'd have over 2 times a, so x equals a negative 3 halves. So negative x equals a negative 1.5. Okay, so negative 1.5, so it's right. Agree with that? Negative 3 halves would be negative 1.5.
Yeah.
Right? Yeah. There's nothing that says it's going to be a nice, neat integer. And don't think you're wrong if you get a fraction. Okay, now we're going to make a table. X and Y. Okay. The axis of symmetry, our vertex has to be on that axis, and that's a critical point to get. So put negative 3 halves in for x. Okay, you might have to do a little work. So let's do, I'm going to change this to a different. Yeah, but I'm going to do it with fractions. Okay. Okay. So I'm going to take that original equation and put in a negative 3 halves in for x. I want to solve for y. So I'd have a negative 3 halves squared plus 3 times a negative 3 halves minus 1. So when you square a negative 3 squared, 9/4. You need to square the numerator and the denominator. Okay, and then multiply. This is like 3 over 1 times a negative 3 halves, so that'd be a negative 9 halves minus 1. That's the same thing as 1 over 1. Common denominator, 4. So it'd be 9/4. Multiply 2 by 2 to get 4, so multiply 9 times 2, be 18. 1 would be 4/4. So 9 minus 18, negative 9 minus 4, you get a negative 13, whoa, negative 13 fourths. Whoa, 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 where are we at here? Mercy sakes. Not going? Did it go? Okay, so the y should be a negative 13/4, which would be a negative 3 1/4, right?
How do you get negative 13/4?
It would be 9 minus 18 would be negative 9. Negative 9 minus 4 would be negative 13. Okay, so negative 3 1/4. Negative 3 1/4. The vertex has to be on the axis of symmetry. Okay, so negative 3 halves, we've already got that. And down, we need to go down 3 1/4. So there's 1, 2, 3, and we're about in here. Okay? Huh? We're on the axis of symmetry. Okay? So you go over, yep, you go down 3 1/4. So you're right about in here. Okay, we should be able to find the other point right here. This one's over 1.5, so go 1.5 over to the other side. So it should be about in here, right? Okay, then let's do 1.5, sorry. How far over? No. I want to go 1.5, so I got a 1.5. Should be right there.
Yeah.
Oh, was I in the middle?
Yeah.
Okay, sorry. Okay, we got it started. Now let's go, I'm going to go, let's try 3. No. Let's try negative 3. Nope, we already got that one. Let's try negative 4. If you put negative 4 in for x. Okay, so go back to your original. x squared plus 3x minus 1. So let's put negative 4 in. Okay, so negative 4 squared, 16 minus 12, minus 1. So 16 minus 12, 4 minus 1, 3. So negative 4, so go over 1, 2, 3, 4, and up 3. 1, 2, 3.
Where do you go?
I'm just graphing this ordered pair, so I'm going from the origin. Okay. Okay, now I'm over, what, 2.5? So now I need to be 2.5 to the right. Okay. Okay, let's try positive 3. 3 squared. Can we do it by just such? 3 squared would be 9 plus 3 times 3. 9. 9 plus 9. 18 minus 1. Whoa. 17. 3 and 17, we're off our graph. Okay, so we're as close as we're going to get. Okay, so just connect these. We would be off the graph if we go much more than that. Okay? Okay? Okay. It goes for, if you're just graphing an ordered pair, so go from the origin. So go negative 4 to, yeah, go from 0, 0. Go negative 4 to the left, and up 3. And that should locate that point. Okay? And then if you're 2.5 units away here, you need to be 2.5 units away here. You really want to use that axis symmetry because it eliminates 3 of the ordered pairs. You can just do it by sight. Okay, last example. And I'm going to get me another, hang on. Need some more graphs. Okay, on this one, they're going to change the directions a little bit. It's going to say find the axis of symmetry. The max or min, and that is called your vertex. The vertex has to be on the axis of symmetry. If it's not, you've made a mistake. Okay? The y-intercept and then the domain and the range. Okay, on this one, the f of x is a negative x squared plus 2x plus 3. So y-intercept you can get pretty quick. Y-intercept is 3. That's your c value. So it crosses at positive 3. So go up 3 and put a point. You want to figure your axis of symmetry is opposite of b over 2a. Get used to writing that formula down so you get it memorized, because we're going to do more down the road. So x equals a negative 2 over 2. My a is negative 1. Negative 2 divided by negative 2. So x equals 1 is my axis of symmetry. I'm going to make it a little bit bigger. So x equals 1. So right along. Also, you should be able to tell by sight, by looking at this, how's it going to open? Yeah, if that a value is negative, it opens down. If the a value is, so we know it's going to look like this. If the a value is positive, it's going to open up. So this one we know it opens down. Okay? Okay, let's figure the vertex point. I know that in my table that the vertex has to be on the axis of symmetry. Okay, so if x is 1, okay, so take your beginning equation and put in 1. And be careful with the signs. Okay, so I'd have 1 squared would be 1 times the negative 1's negative 1 plus 2 plus 3. So I get negative 1 plus 5 would be 4, right? So f of 1 is 4. So my vertex point is 1, 4. So go to the right 1 and up 4. So that's where it starts. That's my actually going to be the max, right? Okay, and if this is 1 away from, then there's another point 1 away over here. So we already know the start of it. Okay, so let's say, let's try 3. Okay, because I know I want to get another point over here. So try 3. 3 squared plus 2 times 3 plus 3. So that'd be 3 squared would be 9. That makes it a negative 9 plus 6 plus 3. 0. So if x is 3, y is 0. So go 3. We're counting from the origin. Go 3 and up 0. Okay, so if that's 2 away from the axis, then there's another one 2 away from the axis over here. So there's another ordered pair at negative 1, 0. Okay? Let's go 5. Well, 5 might be too much. Let's go 4. Let's go 4. So if you did f of 4, so it'd be negative, and then 4 squared plus 2 times 4 plus 3, 16. 4 squared would be 16. That'd be negative 16 plus 8 plus 3, negative 8 plus negative 5. Do you agree with that? So f of 4, so 4, negative 5. So from the origin, go 4 and down 1, 2, 3, 4, 5. Okay, and that's 3 units to the right of the axis. So now go 3 units to the left. So I've got a point at negative 2, 1, 2, 3, 4, 5. Agree? Okay. Smooth curve. I didn't do very good. I can do better. Sorry. I don't want that looking like a V. Smooth curve. Okay. And then come up. Okay. Okay, so now let's go back up. We have found the axis of symmetry. Okay, highlight it, do something for your grader. That's your axis of symmetry. And for all these, it's going to be x equals a number.
So our max would be negative, positive
1, 4. This is our max. That's also the vertex, same thing. Y-intercept was 3. And remember, that is always the C value. The y-intercept is always the C value. The domain. Okay? Now, you look at that graph. Domain goes left to right. Okay? If I extend this graph on out, all real numbers. No, it's just on this one. I don't know. I can't say it's that way on all of them. The domain is all real numbers because you're not leaving out any x values.
Do we have to put in the brackets?
The braces. Yeah, bracket. These are brackets. These are brackets. These are braces. So yeah. It's a set, so it has to be in the braces. Okay, for the range. Okay, what you need to look at is your vertex. Your clue is on your vertex. Okay, if you look at the vertex, your y value is less than or equal to 4. Good deal. So for the range, y is less than or equal to 4. So when you're doing the range, you're going to look at your vertex. Okay? Okay, and then probably need to highlight, you want to help your grader out. Okay? Okay? Okay, that's it.